Hello, everyone.
Hello.
I am Giovanni Fantoni Modena, and I am the CCO of Vitruvian VR. This is the second podcast episode of Vitruvian. The topic today is very technical for tech geeks. It's about the engineering behind the Vitruvian 4XS, the new model of Vitruvian VR. And today with us, we have engineer Simone Bernardini from Extreme Analysis Engineering, and Carlo Panizza, engineer Carlo Panizza, who collaborates with Simone on the Vitruvian. Okay, so the first question I have for both Simone and Carlo is your background. So let's start with Simone.
Hello, everybody. I'm Simone Bernardini. I am a mechanical engineer. I have a master's degree from the University of Padua, and I'm working in this field from the beginning of 2004, and so it's more of 20 years or more or less 20 years of experience in mechanical engineer.
I'm Panizza Carlo, and I'm industrial engineer qualification level PS3, and I'm working about amusement rides since 89. And my work is modeling by means of 3D CAD and make all shop drawing for the realization of amusement rides.
Let's talk about Extreme Analysis Engineering 1 second. How the company started?
Yeah, Extreme Analysis Engineering was born in 2015. And all started with my experience in amusement ride that was born from the beginning of my job, and I was employee in a company that produce amusement ride, and in that period, this kind of company required to have independent engineer in to create a particular design for big Ferris wheel, 55 meter of Ferris wheel, and the train pass only one time in the life, and in that way I chose to start to be independent engineer, professional, and start this kind of job for me. And but in same time. We start also to participate in the European community for developing of the standard for amusement ride, and the job increased a lot. And for me, it was necessary to improve my staff, and in this way create Extreme Analysis Engineering. And now my team is 4 engineers plus me, and 2 persons for administration, and collaborate with a lot of 3D modeling company. I know Carlo, and we start our collaboration in a lot of design, especially amusement ride, because we work not only in amusement ride, but more or less 80% of our design is related to amusement ride.
Let's choose one project that you and Carlo worked together, like a big amusement ride, and describe a little bit the challenges, the technical challenges behind it.
Okay, maybe if you want, we show you a
Sure.
small one, because it's more easy for us to show the 3D model, because vice versa is very difficult to move. And so normally we work to create a kinetic dynamic analysis, and you see my screen?
Yes.
This is a compact coaster. In this case, the challenge was to reduce 320 meter of track in a very small area, and so our design started with this kind of kinetic dynamic analysis, where we define all the acceleration for the passenger, And from when we finalize this kind of information, finally we have the reaction forces on the track, and then we release the FEM analysis. From this kind of information, we share with Carlo all about the 3D geometry, and Carlo start all the construction of coaster. In this case, small coaster, but the challenge here was to reduce the area to release this 320 meter or less, and especially because this kind of roller coaster is mobile park machine, is the traveling, and at the end of the season they dismantle the ride and moving in another park to mount again the ride and start a new season. Carlo, could you please explain?
Well, from the knowledge of Simone Bernardini, we start to modeling all the tracks, all the column, or the base, the station, the vehicle, and all parts for the shop for to obtain the shop drawing, the final shop drawing, to realize the construction, the mechanical construction. Now you see the assembly of the roller coaster, but behind this model there are many drawings. For each part we have a single drawing of parts, of assembly, of mounting assembly. There are many drawings behind this model. This is for the assembly, but we have also, for instance, the assembly of the train, where there are 5 vehicles with 4 people each. And inside the vehicle, there are other many assembly, many groups. I don't know, the safety bar, the bogie, and the frame, all mechanical structure, and all those parts are extracted from a calculation of structural engineer, in this case from extreme analysis engineer.
You see my screen?
Yes.
This is the structural analysis. If you see, it is the displacement during the wait a moment. The FEM analysis after define all the column that Carlo showed you before. We move with the kinetic dynamic analysis. The displacement is too high, only to understand when the train moving to the track. Because this kind of displacement is 100 times the real. It's only to have idea where the train are, but practically we know exactly all the displacement in each position, and then we define also the stress and the fatigue analysis that is necessary to define to be according the standard in safety.
I see.
Okay.
I see.
Perfect. This is completely the story of design for us. So in the end, we started from kinetic dynamic analysis to define all the movement of the ride, all the power of the ride, all the geometry of the ride, especially the acceleration of the ride. And in the end, we define together. We share information with Carlo in this way, and define all part. In the end, we arrive completely to define the 3D model, and in the end, Carlo created the shop drawing, and we finalize our job with our report for the structural analysis. This is in general how we move in this kind of preliminary design, because in the end we start also to implement our mechanical result with the electrical and control system engineer. to define all the control system and all the system to maintain in safety the ride. And in the end, when we are together with the electrical engineer, the control system engineer, and the mechanical engineer, we move into the test body to define the certification of the ride according to standard Peluso.
I see. Very, very interesting. So one short question about if either Carlo or Simone can answer this. Why the Italian tradition in terms of roller coaster is quite well known around the world. So let's speak a little bit about how this started. Why the Italian engineering sector could dedicate to these problems, especially in the in your region. So why we are so good at solving these issues?
Maybe Carlo is more expert on it, but in general, the tradition of amusement ride start near our place here in Bergantino, where there is also a lot of production company. Carlo,
please, Carlo.
My old company start at 1962. Wow. The company that start to build the roller coaster, the old roller coaster, was there was any calculation, only test at the beginning, and around 60 years ago. But I remember that when I started in 1989, there was the first approach with calculation for dynamic, but before there was only test falling down the vehicle, and if arrived at the station, we are all happy. Very. In the past this method was the standard method for calculation, and engineers there wasn't any engineer during the construction of roller coaster in the past. Only good operator, good worker, but the engineer start after with calculation, with dynamic. Now is all another thing. Now without calculation we can do anything.
Right. Yes, and of course everything evolved so dramatically, and then we will talk a little bit about safety regulations that you contributed to write for Europe. But let's dive into the project. Why and how you started working on the Vitruvian VR 4-axis model. Please, Simone, if you want.
Yeah, when we started with the Vitruvian, the approach was the same, because Michele asked me to understand what kind of acceleration the passenger need to be safe. So the first, in the beginning, Michele asked me to move with the kinetic dynamic analysis the passenger in the middle, and to understand what kind of file we arrive to touch according to the standard. And so we implement a lot of information. Then ask to Carlo. Maybe Carlo, have you got something? It's possible Michele show some 3D model about...
Yes, absolutely.
If you let me 1 minute that I come to bring something to show you, a model, until while Carlo show you the 3D model. But it's very important to understand that Vitruvian follow the standard from the beginning. So we know exactly what happened during the kinetic dynamic analysis, and was the first position to establish what kind of driving system is necessary to search, to define all this kind of movement.
This is the main structure of the machine, where there is the base and the mobile parts. There are all movement, the base, the rotation, on first axis, the rotation on second axis, around about the safety device for the man, and we try to do a shape of the seat, a comfortable shape of the seat. And is not finished, of course, because he's working in progress. But more or less, the final result should be like this picture. Is not finished because depending by the size of the motor, but the final result should be like this.
The blue structure is the one we see in all roller coasters around the world, right? The safety structure that comes down to the body.
It is very similar.
So,
Simone,
as I explained you before, during our analysis, we arrived to define that this kind of this typology of ride is a simulator, we know, move in area 5. Area 5 for the standard is an area where it's necessary to have an overshoulder. And in this way, we insert our experience in this kind of sector, and we define this safety that combine double check in mechanical and electrical. So in that way, we establish that all the minimum requirement coming from standard EN 308030 is completely covered, and the passenger are in safety at 360 degrees. In same time, I want to show you now how we arrive to define this kind of information with the structural analysis, with the kinetic dynamic analysis. I share also always my screen. Wait a moment. This is one of a lot of the kinetic dynamic analysis relies to define how the acceleration for the passenger, especially this is the acceleration for the head, because if we maintain the acceleration according to the standard where you see the green sphere, we not define a lot of acceleration because it's practically in the center of the circle, no? And so we prefer to move with our experience on the acceleration for the head to understand if we have some problem for the passenger related to possible jerk or possible shaking that create any not I don't know not correct sensation during the movement of the simulator. And so
it's going to be a wild ride. It's very easy to understand that on Vitruvian people are going to have a lot of
sure fun. Because then we know depend also from virtual reality, no, but in the end all is possible with the Vitruvian. The only thing is that if I don't know if it's possible to speak about this, but I hope so. Vitruvian is designed also to change the seat in the center, and we designed with Carlo a system to dismantle fast way the center of the seat and adjust according the virtual reality coming from the request of the client. And I don't know, we use it for helicopter, we use it for a lot of driving or all that spaceship, why not? And so in this way we know that the simulator can move in fast way and in good way all kind of situation that the passenger or the driver or the pilot won't create during the simulation.
Michele, do you want to add something on the technical side that is interesting to?
Simone and Carlo say about everything about the technical, Now as we know, Carlo says we need the motor to dimension the real shape of the drill. Is what we are looking to find out. We are looking to find the torque motor instead of reduction, brushless, and so on. And this will be maybe a second step, really the market step, because maybe we start with brushless and reduction for the first two machine, and then we are looking for a big slip ring, maybe the first slip ring of this dimension, and torque motor. So we want to have no reduction, less number of pieces that can be broke, etc. More sureness, more power. They used to call muscles. The step motor is not like a motor, it's like muscles. Okay.
Yeah.
And thanks, we are going to patent even the new, I don't know the name in English, the exchangeable interface. Will have contact, will have motor, will have a lot of electronic and electric parts, and will be open and modular to any kind of interface, rover, machine, moto.
Simone, did you want to add something?
Yeah, because Michele is created for us always a challenge, and we are studying the Vitruvian, but Michele thinking also for the future, and he asked me to try to understand how to improve with the new technology also Vitruvia. And in fact, before I running to bring some pieces in 3D printing, because Michele asked us to create a dedicated part. In this example from a roller coaster or amusement ride system, and Michele asked me to create a study for the seat to reduce the weight of the seat or all cockpit we will create for the future, because in this way the Vitruvian will be really too fast to adjust the movement, and in that way also the consume of the power will be less, and we will create a lot of new generation of simulator in this concept, and with a lot of advantages in this kind of application. In the end, we know the 3D model is part of our normal design. If we improve this kind of technology, and we are able to create a very big 3D printing part, more of 1 meter of 1 meter per 1 meter part, with a lot of typology of material, like titanium, like aluminium for aerospace industry, or all the typology that material that will be perfect for Vitruvian. And so only to show how the Vitruvian thinking moving, no? So Michele create a fighting always to implement. Also in the beginning, we are in the beginning of to finalize the 4 axis, but we are moving for the future to be in challenge for a lot of field like aerospace, to accurate and to have a high precision for the movement, So with the touch in fast way, all the criteria to develop a very great product.
Right. No, exactly. I mean, raising the bar is in the DNA of Vitruvian and Michele. So a question about the landscape. We are talking now about the professional training, which have already been asked to deploy the Vitruvian in certain aerospace sectors. But how about the entertainment? You, Simone, know basically all around the world, from the Americas to the Middle East. Where is the entertainment, out-of-home entertainment, of course, the mechanical rides, the theme parks entertainment is going, in your opinion?
There are two phases. The first one, when in the beginning, I think more or less 5-6 years ago, a lot of production company in amusement ride try to create or insert the virtual reality in the coaster, for example. But from my point of view, was not a correct time, because the amusement ride was in that period not ready to accept this kind of technology, because also the kinematic of the ride was not so perfect, and combine virtual reality with this kind of movement, especially of old ride. Only, I don't know, if you have a old ride and you want to improve with something new, like virtual reality, was not a real benefit, because in the end a lot of passengers have a problem for the stomach. So you understand.
Motion sickness. Motion sickness.
Perfect. Yes, it's correct word. But now a lot of company start to have necessity, because in a lot of field there is this kind of necessity to move in the virtual reality. Is part of normal community, no? Because in the end, if you are not in progress, for example, the maintenance team now have this kind of procedure. They're moving with the virtual reality and moving through the ride, and so they understand how to adjust the problem in the ride. And normally the process is moving maintenance. This is the second step, respect the old one, in the maintenance. And if it's working, okay, it's possible to move also in the passenger. And with this concept, the entertainment, also the kinematic analysis is more appreciated, more accurate, because as Carlo explained before, in the past they try the ride moving left, only the potential acceleration, the potential energy is moved not from software but from the real pieces. Now all is done from kinetodynamic analysis, and in correct way, because all time when we finalize a design, we match the analysis, the acceleration from our analysis, respect the real, and we are completely matched together. Mm-hmm. And so with this concept, we are able to define better way the movement, and so also the virtual reality move in perfect way with the kinematic, and this kind of problem is completely removed. The problem that we spoke before. I think that it is a new era about this, and we are open to describe in fast way all this kind of simulation also for Vitruvian. We are sure that no problem related to implementation between right. The movement that we are ready to do with the Vitruvian and the virtual reality. We are perfect.
I see. So how do you imagine Vitruvian fitting this market in the coming years?
We explained to Michele that from my point of view, the amusement park need to have this kind of simulator, and I show this kind of simulation a lot of company, and they told me when Vitruvian will be ready, we are ready to also to sell it, because they know that it's very good simulator. And so this is my point of view, personal point of view, because I bring the simulator like my son, more or less, and try to move with a lot of my client to show the simulator, because I think that me and you, because for me we are a team. We are ready to understand and to share all this kind of great machine for public access in different way. How you prefer, really?
Yeah, so it was a super pleasure to have you all. It's been very insightful, and we truly hope that together we are building a very, very interesting machine for both entertainment and training sectors, and very safe, because of course Vitruvian VR, as all the rides you develop, is going to respect very, very high standards of safety regulation. So again, thank you to all, and hope to see you soon on the Vitruvian design. Bye-bye.
Thank you, Giovanni. Thank you, Simone. Thank you, Carlo.
Bye.
Ciao.
Bye-bye. Thank you.